Gel electrophoresis is a technique that separates DNA based on its size, and we do this by applying an electrical current to a gel. DNA has a net negative charge, so this means the DNA will move towards the positive terminal. The DNA is pulled through an agarose gel, and if you zoom into that agarose gel, what you see is little holes or little pores in the gel. So the DNA is tugged through these holes by the electrical current. Shorter pieces of DNA move through the gel more quickly than longer pieces of DNA. When we did our PCR, all of the PCR products are the same size. So that means when we load our gel and the DNA runs through the gel, all of those DNA molecules accumulate at the same point in the gel, and you'll see a nice, crisp band. Our gel is now set, so now we can move it into our electrophoresis machine. We have to take out the comb from the gel, move it into the electrophoresis machine, and then we have to pour some buffer into the chamber. Now we're ready to load our DNA onto our gel. The first thing we load is the size standard. Sometimes it's called a ladder. And this is a reference that helps us to figure out how big our pieces of DNA are. Once we've added our marker, we can then load our DNA samples. In this case, it's a PCR product. Once all of our DNA samples have been loaded onto the gel, we put on the lid and then we press go to start the electric current, and our DNA will start to migrate through the gel. Once the DNA has finished running through the gel, we can visualize the DNA by turning on a blue light. Once the blue light is on, you'll see the molecular marker or ladder. This is the size standard, and then what you'll see in the other lanes is a nice clean band which shows your PCR product.